Alright guys, I'm sorry I'm sick when I'm making this video, so if I sound awful, it's because I'm sick. But today's goal is to add and subtract polynomials using our knowledge of perimeter, and then we're going to multiply polynomials using our knowledge of area. So we know how to add and subtract them, we know how to multiply them, we're going to take it a step further and kind of apply a different concept to it. So first off, let's talk about what perimeter is versus what area is. Now if you remember perimeter from middle school, perimeter is when you add the outside. Okay. Area is when you multiply, and we're going to be dealing with squares and rectangles, and if you'll remember, area is going to be length times width. So we're going to have L times W. Okay. So when we look at perimeter, some things you'll notice is if this top side is 3 of a square, then we know this bottom side is going to be a 3 as well. And so same thing, if this left side is a 3 of a square, my right side is a 3. So when you do perimeter, you are going to add 3 plus 3 plus 3 plus 3, which is going to give you 12. Another way you could have done that was I have 4 3's, which would give me 12. Over here, when I think about perimeter, if that top side is 8, my bottom side is 8. And if my left side is 3, my right side is 3. So if I were to find the perimeter of this, I would have 3 plus 3 plus 8 plus 8. Okay? So that would be 6 plus 16, which would give us 22. Okay? So that is how you find perimeter of a shape. Now, if we talk about area, you're going to be doing area equals length times width, which in this case, this right here is your length, and then this is your width. So you would have 3 times 3, so the area of that figure would be a 9. Okay? Same thing for this rectangle. Here's my length, and here's my width. Okay? So I would have for area, I would have 8 times 3, and so my area would be 24. Okay? So again, that's a little bit about area and perimeter if you kind of forgot it since middle school. But guess what? We're going to add polynomials to this stuff, okay? But first, just kidding, we're going to add polynomials. All right, so it wants us to find the perimeter and area of each figure, okay? So let's start off with perimeter first. Perimeter I know means add. So now a tricky thing is you're not just going to add 2 sides because there are 4 sides. So this bottom one is 2x plus 1, and this right side is 2x plus 1. So there's 2 kind of ways to write it. You could write it out the long way. Let's say 2x plus 1 plus 2x plus 1 plus 2x plus 1 plus 2x plus 1. So you could write it out 4 times because you've got 4 sides. Or what you could do is say, I have 4 2x's plus 1. This one's going to be a lot quicker. So I'm going to distribute. Now we get 8x plus 4. So this right here is my perimeter. Okay. So now when I think about area, I know area is going to be length times width. Okay. And again, here is my length. Here is my width. So how you would set that up with a polynomial is you would say 2x plus 1, and then your width is going to be 2x plus 1. So when you've got polynomials and you're talking about area and you have to set it up, you set it up with parentheses just like we've been doing in the past, okay? So this, you guys know how to do. It's multiplying polynomials. So first off, 2 times 2 is 4. And then x times x is x squared, okay? Next off, 2x times 1 is just a 2x, okay? When I do my inside term, I would get 2x again. And then when I do this last term, I would get a plus 1. Okay, now remember that is kind of the shortcut to do it in your head. And when you combine like terms, you would get 4x squared plus 4x plus 1. Okay, this would be our answer for area, okay? All right, so that is, again, how you find perimeter and area of a square or rectangle, which is what we're going to be dealing with. All right, so now a little bit of a more complicated problem. I've got a box within a box or a rectangle, okay? So how would you find the area of the light blue region? So how would we find this area here? So think about it like this. This is a house. This little blue purple part is a pool. And you've got to lay brick around the pool. So how much, area, square footage do you need of brick, okay? So that's kind of like a real world example of this problem. So what you have to do is you first need to find the area of the whole floor plan and see what the area of the smaller part is. And if you're just looking for the outside, you're going to find the difference, so you're going to subtract, okay? So if it ever asks you to find like this outside region, you're going to find the area of the larger one. You're going to subtract the area of the smaller one, okay? So the area of the larger one. So remember, area is length times width. So area would be 25 times 25 of the large one. So I'm going to put area of the large one. So 25 times 25 is 625. Okay. To find the area of the smaller one, I'm going to do length times width again and do 7 times 2, which is 14. Okay. So again, I'm going to do large minus small. And since these are just numbers, I'm going to do 625, subtract 14. Okay, so 625 take away 14 is 611. So that is the area of this blue region right here. Okay, so that is kind of how you think about this problem with just numerical values. But what we're going to do today is we're going to actually apply polynomials to this concept. So if you remember area of the large minus the area of the small, you will be fine. Okay. So I'm going to do this problem, and then you're going to do the last problem on the back, and then we'll be done. Okay. So first thing, it wants us to find the area of the green region. So I need to find this area, this outside area. So again, I'm going to do the large minus the small. Okay, so first off, the area of the large, okay? The area of the large is your length times your width. So again, you got to set those up with parentheses. 2x plus 3, 2x plus 3. And we're going to multiply those, okay? So let me go ahead and do that. Let me do this one kind of the long way of showing my work. You're going to do 2x times everything on the right. You would do 3 times everything on that right side. I would distribute and get 4x squared. Distribute and get a plus 6x. Distribute and get a plus 6x again. Distribute and get a 9. So again, you don't have to show this step if you can kind of do that step in your head. But lastly, combine like terms. So your answer is 4x squared plus 12x plus 9. Okay, so this is the area of that large one. Okay, so now I need to find the area of the small one. Okay, so the area of the small one is, here's my length and my width. So I would say x minus 7 times x minus 7. Okay, got another binomial times a binomial. So I'm going to do this step in my head real quick. So x times x is x squared. X times negative 7 is negative 7x. Negative 7 times x is negative 7x. Negative 7 times negative 7 is a positive 49. Last step is to combine like terms. X squared minus 14x plus 49. Okay, so here is my area of that small figure. Okay, all right, so now one more step. And this is going to take us back to adding and subtracting polynomials, because I need to subtract. So you have to set it up a certain way, or you will 99% of the time get it wrong. So first off, the area of the large is this one right here. So remember when we wrote parentheses minus parentheses, that's what we're going to have to do here. So 4x squared plus 12x plus 9 was our large, minus the small, which was x squared minus 14x plus 49. Okay? So now again, if you know how to do this step in your head, fantastic without showing your work, but I'm going to show all of my work. And my screen's going to get small. Okay, so first off, when you're subtracting, you're going to distribute that negative to everything. And that's going to change the sign to negative x squared. It's going to change that to a plus 14x, and it's going to change that number to a negative 49. I'm going to go ahead and bring down this sign. Last step is to combine like terms. So I have a 4x squared minus an x squared, which is a 3x squared. I have a 12 plus a 14, which will be a 26x. And then I have a 9 minus a 49, which is going to be negative 40. Okay? So we're done. So this right here would be the area of my green section. Okay? So yes, I agree, it's tons of work. It's a lot of steps. You've got to multiply one thing, you got to multiply the other, and then you have to subtract them, okay? But that is what you're going to do to find the area of a shape when you take something out of the center, okay? So if you have questions, let me know. Otherwise, I want you to try the one on the back, the very last one about the orange one, and then I will show up the answers in a second, so please press pause and try this one on your own. Press pause. So when I found the area of this orange region, again, you have to find the large minus the small. So my equation for the area of the large is 5x minus 2 times 5x minus 2. Once you distribute that out, you should have gotten 25x squared minus 20x plus 4. Okay. Then you got to find the area of the small figure, which is x plus 1 times x plus 1. Once you distribute that out, you should have got x squared plus 2x plus 1. Okay. So area of the large minus area of the small is what I set up right here. And then I distributed my negative to everything on this side, which made it negative x, negative 2x, and negative 1x. So when I combine like terms, I did 25 minus 1 and got 24x squared. Did negative 20 minus 22 and got, or minus 2 and got negative 22x, and then 4 minus 1 is a 3. So this right here is my final answer for the area of the orange region, okay? So that's how you use area and perimeter in multiplying polynomials. So thanks for watching, and now you can start practicing.